Welcome. We discuss about queue. We have few points here to discuss. One is what is a queue. We talk about queue implementation. Queue is a dynamic data structure, and you understand that we have a lot of practical applications in the world which is based on queue. We need to talk about some applications of queue, priority queue, and also talk about some applications of priority queue. So talking about the next item is what is a queue. Queue is absolutely a linear data structure. Why? Because we keep one item one after the other, and it follows a dynamics, of course, but you can understand that you insert element from one end and leave element from the other end, remove from the other end. So in queue we basically have two ends. One is called back, another is front. Sometimes back is also called rear end. So somebody is inserting, remember we are standing in a queue to buy something, to give our voting, to do banking, and during this COVID period we have social distancing. So it's a kind of queue. So whoever is at the first, he lives at the first. So it's actually kind of first in, first out kind of data structure, FIFO data structure. The first item to be inserted, which we call, there are two operations in queue. We know one is insert, we call NQ operation, and another is delete or remove, we call DQ operation. So queue operations are generally three. One is in queue operations, you insert an element at the rear of the queue, that means you're inserting from here, and DQ, delete an element from the front of the queue, DQ, and get head, get the element at the front without deleting it. That means you know who is standing at the first. Now, talking about queue, you can see a situation when we say NQ1, and then this is my rear and this is my front, and then I do NQ5, yeah, and then I do DQ. DQ is removing because 3 left the queue. This was the front, 3 is at the front, and then when you do NQ, one after the other is coming. When you say DQ, the 3 is gone, and then DQ again, 1 is gone. So that means somebody is leaving from the front and somebody is entering from the back. So DQ operation and NQ operation is clear, right? So you can go ahead with the implementation. I can show you an interface. It is a Java implementation, but I will be talking about C implementation also in the class. We can have three types of implementation: Q as array, Q as circular array, and Q as linked list. So talking about Q as array, we basically have an array inside this class. It's actually object-oriented implementation, but I will show you the C implementation is very simple. We try to manage the array for the queue, and we basically have the get head and the enqueue and the dequeue operations. I will show you the code separately. Talking about the circular array. Now circular queue is like you are actually entering in a circle. It's like everyone is, there is a enqueue. You can see the front and the rear. Front means somebody is going to leave from here, and rear means somebody is entering. So NQ operation always takes at the rear. Now NQ operation will result in somebody is leaving from the front unless it is field. So what happens by modular arithmetic for computing array index, we can have Q implementation in which each of the operation NQ, DQ and get has complexity of the order of 1. That means it's a constant time operation. Alright. You can see here front, when you do DQ, that results in, you can understand that you are actually DQing, means you are taking out someone from the queue, and there is a change in the front. You can understand somebody left from the front, and the B is now pointing because this B, before that there was S. So S left when you say DQ. NQ means enter, DQ means leave, so you understand clearly, right? So this is a circular array implementation. We'll see the C code differently. This is actually Q as linked list. Application of Q, there are many applications we actually apply. We provide process queue in our operating system. There are many queues in the operating system because resource sharing is managed using queue. Access to shared resource, you can see printer is using queue. There is multi-programming, which is practically using queue. Indirect, there are many applications, auxiliary data structures, component of other data structure. Queue can be part of that. And there are simulations. We'll take a look at it. I'll show you this simulation in the discussions. Priority queue is like a queue where every member has a certain priority, and the higher the priority, the member has privilege to leave the queue earlier. So a priority queue is a queue in which dequeue operation C removes an item from the front of the queue, but the enqueue operation insert items according to their priorities. So you understand that enqueue is operating based on priority. The higher priority item is always enqueued before a lower priority items. That means if someone is entering like a VIP, he or she comes and stands in the front. So that's actually priority queue. So priority queue and implementation is like this, and we discuss actually in the code. There are many applications of priority queues. Huffman code, very popular algorithm for code compression. Disaster algorithm for shortest path. Prim's algorithm, CPU scheduling, they are all actually based on priority queue, and we also have a discussion in the Google Meet. And I hope you enjoy this discussion and keep learning data structure.